So I've seen a few posts below my offset dumper thread asking how you can use this, how to generate your own patterns, how patterns are working and stuff like that. So in this video I will explain how you can generate your own patterns, how those patterns are working, how pattern scanning is working, and how to use this offset dumper. So the first thing you will need is this cheat engine here. Make sure to follow this tutorial. You can also use IDA instead if you want to use it and if you know how to use it already, but I prefer using cheat engine. You can also use the SigMaker plugin here, which we will use in order to generate those patterns and signatures. And yeah. So in order to understand how patterns and pattern scanning is working in general, you need to know first how offsets are working and how offsets can be used. So I will explain that in a second. For example, in League of Legends I have currently my position value or position address within this field. This is the raw address, the raw memory address. I don't have any offsets right now, as you can see. And if I open it in the disassembler view, you can see that if I move, everything changes around. So if I restart the game now, you will see that my position address is not the same anymore, or at least that if I try to read my position using this raw address, it won't work anymore, or it will give me a random result which is not my position anymore. Alright, so now we are back in the game, and if I reattach cheat engine to League of Legends now, you can see that if I move around, the raw memory address doesn't work anymore. It's at a random location where there's no memory. However, the other address, which I'm using together with offsets, is working fine. Currently the offset of the position is 220, and this way the program is able to still find my address. So this just explained what offsets are for, but not how you can use them yourself and how to understand them. So if you don't know what offsets are and want a more in-depth guide or tutorial about that, you can just read my post here. It's very basic and very simple to understand, so I will link it in the thread as well. So before I continue with pattern scanning, you need to understand this code first, and trust me, it's very easy to understand and very easy to follow. So let's pretend you are a game developer, so we are taking this from the perspective of the game devs. And we are coding our own game right now, which is this code here. And within our game, we have our own player. And this player is able to deal damage. Also, this player has his own health. And in order to deal damage, we need the do damage function. And within inside this do damage function, the health of the player will be reduced by the amount of the damage taken. So let's go back to the structure. Inside the structure, we have two variables. One is the damage, as already said, and one is HP. Most of the time, those variables are separated by either 4 or 8 bytes within memory. In this case, they are separated by 4 bytes, which means that damage has the offset 0 and HP has the offset 4 within inside memory. So if we take a look at the do damage function inside the disassembler now, which we can use with, for example, cheat engine, inside the memory view, you will see this. This is the do damage function inside the memory view. On the right side you can see that XMM0 is writing the new health to the player. So you can see that 4 is still the offset of the health. This way you know that, for example, if you use cheat engine, that the health offset is 4. Most of the time you will write down this pattern alt.exe 12240 as address in order to keep your offset updated. For example, if the game has an update, you can just go back to this address, take a look at this function here and see that, for example, the 4 changed to an 8. This way you know that the health offset changed from 4 to 8. However, let's take a look what happens if we update our game. In this case we will add a new function, which is here, and now we are able to also heal the player after he took damage. In able to do that, we add a new variable to the structure of the player, which is here, which is the amount of the heal, and we add the heal function, which heals the player, and we call the heal function down here inside the main function. As already said, on the left side, the damage offset is 0 and the HP offset is 4. However, now that we have the heal in between the damage and the HP, now the damage is still offset 0, the heal offset is 4 and the HP offset is 8. So the HP offset increased by 4 bytes from 4 to 8. If we go back inside the doDamage function now within the disassembler and take it side by side, this is the old code, this is the new code, you can see that within the old code the offset changed from 4 to 8, as already said. However, because of the new function that we added here and all the new code, if we take a look inside the main function in a second, but first let's take a look at the heal function. This is all the new code from the heal function that we added, that will be inside of the memory now. So this code will be added and will be somewhere in between. And because of that, if we take a look at where the old main function, which is this one here and this one, this is the old one and this is the new one. If we take a look where the old main function started, it started at 12,460. However, now that we added the new function to the code, now it went down from 12,460 to 12,400 E0, which is quite a bit, which basically means that the code went down. You can see it a bit better here. If we take a look within Indepth, you can see that, for example, this was the old code, this is the new code. Because of the new heal inside the main function, you can see that 2 move instructions have been added here, which were not there before. Same with the heal call. Since we added it here, it will be added to the code, and because of that, the old code, which was here before, will drop down to here. So if we go back to the doDamage function and take a look at the address of the instruction which writes the new health to the health of the player, you can see the address was 12,240, which we wrote down before, right? In order to update our offset in case the game get updated. However, if you take a look on the right side now, which is the updated side, you can see that the new address of the health instruction is at 12,250 now. So it increased and moved down by 10 bytes. Which basically means that if we search for this address, which we wrote down before, inside the new patch, that instead of landing here, we will land somewhere here. Well, it's not that bad right now, but many games like League of Legends have really big patches, and then the instruction won't only move by 10 bytes, but many more, like 400, 500, and you won't find the code anymore. So in this case, we can use pattern scanning and patterns in order to find the address or the instruction that is writing to our health again in order to find the health offset. So let's take a look at all those bytes in here. If you compare them side by side, you can see that all of those bytes are the same like those one on the right, except the highlighted ones. Here it was for 6, here it is 3, 6, CD, C2, 4, 8 and 4 and 8. But all other bytes are still the same. So in this case, you can use pattern scanning or patterns in order to find this exact address, because as you can see, this address has the same bytes except the 4, which changed to 8, but we can use those bytes to our advantage in order to find this address again. So now I will show how we can do that. Alright, now I can start explaining how patterns are working and how pattern scanning is working in general. So, let's take a closer look at this instruction and let's pretend that this is not notepad.exe but this is League of Legends. And that this instruction is, for example, the call to write inside the League of Legends chat. Now we want to generate a pattern for this instruction in order to find it after an update again. So, let's take a closer look to the bytes again, and we just copy down the bytes here. So it's A2, 13, 13, 15, 95, 77, 77. So just that you understand that those bytes up here are just the same bytes as here, but from the left to the right. This is not our pattern. These are just the bytes from above here. So we can use them for comparison. Let's just create our pattern now. Since we want to create a pattern for the notepad.exe instruction, we start creating our pattern at this byte. So we use 72 FB and write them down in order to create a pattern. Now our pattern is 2 bytes long and consists out of 72 and FB. So What is this pattern now? How can a pattern scanner use this pattern now? Well, a pattern scanner compares this pattern with the memory or with the bytes of the memory one by one. So for example, it checks if 7.2 is the same as A2, in this case the byte up here, and if FB from our pattern is same as the byte here from up here. In this case our pattern doesn't match this byte array or the byte array here, so it says it's wrong and it continues with the next byte array. So it basically just compares the pattern with each byte from the memory until it finds a byte array which is matching. In this case it found a matching byte array, which is the byte array here, 7.2FB, which is unfortunately the same as the byte array from our instruction, so it finds the wrong address too early. Because we don't want to find it here, we want to find it here, right? So what we can do in order to prevent that, we need to make our pattern more unique, so that our pattern is there only one time inside the entire memory of the game. So in order to make our pattern more unique, we add the next byte from the next line below our instruction to the byte array or to the pattern. So now our pattern is 7.2FB24. Unfortunately, it's still matching with the instruction from above here, as you can see, 7.2FB, and 24, which is also 70FB24, 70FB24. So those bytes are still the same and our pattern is still matching with the previous wrong instruction. This means we have to make our pattern even more unique and just add the next byte again to our pattern. Now you can see that our pattern doesn't match with the byte array from the memory again, because now it's 7.2, 7.2, FB, FB, 24, 24, and EF, E6. So because of that E6 and that EF, it is wrong and it continues with the next byte inside the memory until it finds our right instruction here. And in this case, if it finds the right address or the right pattern, which is this one, it will just return our address, which is notepad.exe plus 8d. And then we have this and we can go inside Cheat Engine, enter the address after a patch and find exactly that instruction with the new offset again. However, what happens if the game updates? Right, the offset changes, right? Because it can change from 8a to 7b or to 4a or something like that. So what happens if the instruction or the offset of the instruction changes from 8a to 7b? Take a look at this byte again. You can see it changes from FB to EC. And because of that, if we take a look at our pattern, before it is 7.2 FB to 4 EF, and if we want to use our pattern, the same pattern from before, with the new patch, it won't match anymore, because now the FB changed to EC, right? So you might think, are patterns not as useless then as simple offsets? No, because we can just use something called wildcards, and in this case, we just replace the FB with question marks. So you might think, what is this? Why do we use question marks here? Basically, we use question marks for all bytes inside the pattern that can change after a patch. So, if you remember correctly, before we wrote down our pattern, which is 7.2 FB to 4 EF. And in this case, we know that after a patch, the 8a can change to, for example, 7b, which basically means that this FB pattern here, or this FB byte, can change to something else. In this case, inside our pattern, we don't write down the FB, which can change, but we replace the FB with question marks instead. Because of this question mark, pattern scanners won't compare this pattern with the pattern above, so they handle it like there isn't any pattern, right? So this way, our pattern will be working again, because it doesn't compare the wrong pattern with the wrong pattern anymore. Now we only have right patterns. So basically, if you know that, for example, the 7b here changes, or this 8.6 changes from FB to 4.2, you don't write down the entire pattern like this, but you write down the pattern like this, with question marks in between everywhere where the byte may change. So let's say we want to get a signature for this address. What we can do now is we just write down the bytes to 0, 6, 9, 3A. Make sure that it says an array of byte here and press first scan. Now you can see that this scan is directly basically showing us the address of this one here. So this is working fine now. However, if the offset changes now from, for example, 3A to 4B again, and we try to use this pattern again, you can see that we won't find that pattern anymore. And since to 0, 6, 9, 6, 9, 3A, 4B, this is not correct anymore. Instead of using 3A or 4B or the offset, we will use a question mark. So now if we scan again, you can see that we find many more addresses, but not the one that we are looking for. This means that our pattern is not unique to this address anymore. In all of that memory, there are many more patterns which are equal or the same. In order to get the correct pattern, we can add the byte of the next line, which is to 0, and we hit new scan. Now it's down to 205, we add 44. Now only 45 are found. We add 4F. Still too many. And we just add bytes until we have a unique pattern like that. So, alright. Now that we also added this line to the byte pattern, you can see that now it is able to find the right location, which is 6.8. The only issue with that is that you can also see the offset 6F here, which is also within our pattern again. And after some updates, also this pattern can change again, for example to 6A. If we try to use this pattern again, you can see that it's not working anymore since we are using 6F. Here it says 6A now. So also for this offset, we need to use the wildcard again. So basically for all OP code, for all bytes that are possibly changing after each update, we will use a question mark. We use only one question mark for 2 bytes. So basically if 7.4 changes, we use one question mark. If 7.4 to 0 changes, we use 2 question marks with basically space in between each time. Now if we scan again, you can see, since we added the question mark, now we are able to still find the address even though that we change also this address. So this is basically how pattern scanning is working. We generate a pattern that is unique for this address, for the whole memory region. And we make sure that we add question marks or basically wildcards for everything that is possibly changing. So now you may ask, how do I know if a byte is changing? I'm a newbie, I have no idea about this, and if I want to create my own pattern, how do I know if a question mark should be inside there or not? Well, that's a good question, and here's the answer for it. There's a simple plugin for Cheat Engine which you can download here. You just press here and press on download, and if you downloaded it, you can just go inside settings and inside plugins, press on add, choose the DLL and make sure that it's checked here. And if we go inside the memory now of any game, so just let's attach it to my own Cheat Engine, and we go to the base address. Oh, in this case it's just my browser, but it doesn't matter. So we go to the base address, and let's say we want to create or generate a pattern for this address. So instead of manually writing down 726F, 67, 7261 as a pattern, you can just press right click, generate signature, and press no for code style, for IDA style, and yes for code style. In this case I will use no for IDA style. And if we paste it inside here, you can see that it automatically generates a pattern with those question marks. So in this case, it generated the pattern 7.2 question mark. So you know that the 6F, the C5 in this case, is probably changing after an update. 6.7, 7.2, question mark again. So basically this means that the BA is probably changing after an update because it's a variable. And then 6D. So in this case you can just use the SigMaker plugin for everything. It will generate a valid signature which is unique, so you don't have to check it if it is unique or not, because we can just search for this signature inside Cheat Engine. You can see that we only find one result. If we remove the line at the end, you can see that it will probably find more results, so this is not unique anymore. So we add it back. So the SigMaker plugin is always creating unique working signatures, and those signatures should work fine for like 20 patches or the next few months in the most cases. Okay, since I showed how everything works now, we can continue with generating real examples for League of Legends. For example, generating a pattern for the local player. So, one thing you need to know is that you will need working updated offsets in order to generate patterns. Otherwise, if you generate a pattern for an outdated offset, this will be completely useless. This won't give you updated offsets, so make sure that you have updated working offsets before you generate a pattern. If you only have outdated offsets right now, you can go inside the League of Legends reversal thread in order to get updated ones. You can find them here, or otherwise just ask for the offsets you need, and maybe someone is helpful enough to send you them. And yeah. Something else you need to know is that I am using Cheat Engine in order to generate all those signatures. You can also use IDA instead, but I prefer Cheat Engine since it's a lot easier and faster to use. If you want to use also Cheat Engine, make sure that you followed my undetected Cheat Engine tutorial. Otherwise your Cheat Engine won't work for League of Legends. So make sure that you really followed all the steps within this video or within this thread, and then you can continue. I will also link this thread, by the way, inside the description. The last thing you need is the SigMaker plugin, which you already should have been installed, since I explained it before. Also within your extras, make sure that you have all those checkboxes checked, and within your debugger options, make sure that it says use DBVM level debugger, otherwise you won't be able to use it. Okay, so now let's say we want to get or generate patterns for League of Legends. What you will need is an updated offset, which is working fine, in order to generate a pattern. So in this case you can go to the League of Legends reversal struct and offsets thread, go to the last page and search for the offsets you want to use. Most of the time people are updating or writing updated offset lists here. For example, we can use the minion list here. This is the offset for the minion list, which is updated for 1319. Now what we are going to do is we press add address manually, and within this field we enter the base address, which is League of Legends.exe plus the offset, and press OK. Now if you go to that memory address, you can see that's basically all scrambled up and not really useful. This is because first we need to press right click, find out what accesses this address, press yes. This will attach the debugger to the League of Legends game, and in order for this to work, you need also to make sure that you really followed my tutorial here, and that you have within the settings all of these extra settings enabled, and that you use the DBVM level debugger. Alright, so did that. You can see this window here. You press stop and sort for count. Here you can see the instruction which has the most counts. We go to show this sampler, and here you can see the instruction which is accessing our minion list the most. You can also see the updated offset here, which is 21AC7F0. This is the offset for the current minion list. And now if you want to generate a pattern, we just press right click using the plugin, we generate the signature, press no, and now we have a working signature. Can also go to array of bytes again, search for this array, make sure that it says League of Legends here, make also sure that it's everything like this, press first scan. As you can see, it directly finds the address here. But now you think, if I search for this pattern now, I get this address, but I don't get the real offset for the minion list. So what you have to do is you need first to open up this address, press Ctrl and D. And within this window you can see on the right side the instruction that is basically accessing the minion list, and here you can see 21AC7F0, which is the offset. This way you can always get the updated offset. However, if you don't want to do all of that manually, just like inserting the pattern, then going to that address and getting the offset here, you can use my offset dumper. You just insert the process, League of Legends, then the module, which is also League of Legends, and here you just insert the pattern. You can also write minion list double point and just search for the pattern. And just like that, it will find the minion list with the updated offset. You can compare it with the memory view again. Let's open it up. As you can see, it says 21, 1, AC, 7F, 7F, 0, 0. So just like that, you have a working pattern which is working fine for the League of Legends minion list. So in case this game updates now, you can just use my offset dumper together with your pattern. Press search for pattern and it will give you the updated offset. Sometimes those patterns will also break after like 20 patches, but most of the time they work up to 8-9 months or stuff like that, so you don't have to generate new ones then. And again, this can be tricky for certain offsets like the health. So let's say we want to generate a pattern or a signature for our health offset. In this case I have the health offset here, which is again the hero list, the local player, and the health address or health offset, which is 1058. If I sell something in the shop, you can see that the value changes, which is basically health items that I'm selling right now. I also can buy health, which gives me more health. And again, we are not able to directly see in the disassembler the offset, because this is the memory where my health is basically. So first, press again, right click, find out what accesses this address, find what accesses the address pointed at by this pointer. And now you see this value here, or this instruction. And if we take a look at it, you can see that there is nothing like an offset which basically points to our health offset. Also, if we take a look down here, inside all of this code, we don't find any address which is near to 1058. So this is not the address we are searching for. So in order to find the correct one, do it again. And this time we sell or buy health inside the item shop. And each time we buy health, you can see that this count goes up. So another instruction just showed up. In this case, this is the right instruction we need. Also again, if we take a look, you can see that there is nothing like 1058 here. So at the first glance it looks wrong. However, if you take a look at the code down here, at the instructions, this is not the right one, this is not the right one, but hey, here we have 1058 RCX. So you can write down inside your notepad or wherever that for the health, RCX is the correct offset, and then you generate the pattern for this one. So just do it like that, generate signature, and we enter it here again. And let's say now that the offset changed and the game updated and you want to update your health offset. You just search for this pattern, you press new scan, first scan. That's where you find the address, which is this one here. So, and how do we find the offset now? You may be thinking, since the offset isn't right here and it's not visible. So one thing you can do is you press right click, find out what addresses this instruction accesses. And now you see many values, if you change it to float, which are health values. And if we take a look at our health, which is 1552, it's none of the health values within this field. But if you remember, the instruction that we just found only activates or hits once we sell or buy a health item in the shop. So the same we have to do again now. We buy a health item, and now you can see that this one added these two addresses. So one of those addresses is our max health, and one of those addresses is our current health. So we just add them and double click it, so to add them, just did that already. And now to find out which offset this one has, you can press right click again, find what accesses this address. This is not the right one, since again the instruction only activates once we buy something within the shop. So let's buy something or sell something, I mean a health item. Now you can see the instruction again. And if we go to RCX, since you remember that the offset is within RCX, now it says 1070. Since it didn't update or anything, 1070 is probably the offset for the max health. So we do it with the other instruction, the other address, and check it again. Let's sell a health item. And down here we can see RCX is 1058 again. So this way you know that you can just enter the pattern, hit new scan, get the address, go to the disassembler of the address. Then we find out what is writing or accessing this instruction. We sell something in the shop or buy something in the shop which gives us health. We need to load again, get our health down here. Find out what accesses this instruction or this address. And again, like that. Now we have our offset, like here. So as you can see, this is a bit harder and a bit, more advanced than the other methods. But you have to do that for some offsets manually or for some patterns. Since my pattern scanner doesn't do that currently. Maybe I will add it later, but currently it doesn't do that, so you have to do that manually. You can also do that with IDA instead, which is probably a bit easier than this method. But I don't use IDA that much, so someone else maybe in the comments down below can explain how it works. Also, the last thing that I want to show you is that patterns can look different. For example, if you take a look at this pattern, you already know how to do this. You just insert it here, change it to array of bytes and hit scan. This way we find the array here and the offset, which is 2215E60, which is the same one like in this thread here. However, there can also be different patterns, which say NTL, DLL.DLL for example. And in this case, you have to select the module that you have to scan in. In this case, we switch from League of Legends to NTDLL.DLL. Then we copy the byte pattern, insert it here, and this way we find the correct pattern. So make sure that if there is a module before, that you also copy the module or change the module to the correct one. The last thing is that there can be patterns like this one. This is an IDA pattern, and we can also generate this one using the Make Signature plugin. However, we can't just use this one in order to scan for the pattern that we need. Like if you just hit scan, we won't find it, right? So what we need to do is, instead of copying everything, we have to type it out, like 20 and space 60 00 64 65 and so on. Also, what you need to know here is that there is a mask behind it. So in order to use this mask, if you know already that question marks are basically wildcards, and we have to implement this wildcard for our array of byte pattern here. So in this case, we take the first byte, which is an X, which means that this is a valid byte, which we can search for. Second byte, which is again an X, a valid byte. The third byte, which is 00, and here it is question mark, means instead of writing 00, here we have to type in the question mark. And it says 64, XXX and so on. So basically you count from the left and here also from the left, and for each question mark you see, you have to replace the 00 within question mark in Cheat Engine in order for it to work. So the last thing that I want to show you is that, again, here it says the module. We select the module and it says pattern, copy that pattern and search for it, and we open it up. And now you can see the +1 here. What does this +1 mean? Well, some offset dumpers will need this +1 in order to understand what they have to dump and which offset they have to return. For example, if you don't add that +1, some dumpers will return the B8 as an offset. However, if you enter this +1, it will skip the first byte and go to the second one, or to the one here, and return that address as an offset. So for example, if you want to get the 0 true address here, you get the pattern for this one, and then you say +2 because you want to skip the first byte, you want to skip the second byte, and you want to get the third byte, the 20, as an offset. Here again, if you want the E6 as an offset, you say +2 because you want to skip the 02, you want to skip the 69, and you want directly get the 6E, the offset. However, you don't have to do that for all dumpers and for all patterns and stuff like that. It's used for some dumpers, but the dumper that I released here doesn't need that at all. You can do it without that +1 thing. Yeah. Alright, so that's everything you need to know about pattern scanning, generating patterns, and how to use my program. Just generate new patterns when you have updated offsets. I'm sorry for everyone who doesn't have updated offsets and has outdated offsets only. You will need to get updated offsets before the patch, and you have to generate the patterns, and then you can use those patterns after the update in order to update your outdated offsets. So if you only have outdated offsets right now, this method won't work for you. You will need to find updated offsets first in order to generate patterns, and then you can use those patterns in order to update your offsets. I hope this helped a bit, and let's see you in the next thread.